Rahim, starting with the name of Fatma Jalla, who is the most merciful and beneficent. This is our topic of final year project. My name is Karamat Ali and I am student of Civil Engineering Department, and this is our final year presentation. And the topic of this presentation is effect of contact pressure on lateral capacity of pile in a pile raft system. Our supervisor was Dr. Pandemir sir, and my group members are next. My group members are Muhammad Karim and Muhammad Zishan. For introduction, I would like to call Muhammad Zishan. Please.
Assalamualaikum. My topic is to address the topic. My name is Muhammad Zishan. My introduction: pile raft system consists of pile and raft in a combination. The pile the raft and the piles interact to transfer load to the ground is called pile raft foundation and pile raft. Pile is a cylinder member and it is used to transfer load of superstructure to the hot strip of efficiently. It can transfer load in three ways: skin friction and bearing, and friction and the bearing. Next, and pile raft provided both stiffness and load resistance, and pile and acting as settlement reducer. Pile raft foundation are regarded as very complex systems involving many interaction factors such as pile to pile, pile to raft to side, and the pile to side. In the pile raft system, load from the superstructure is shared between raft and the pile. We use raft foundation where side strength is weak and load from superstructure is high. Almost half of century ago, first attempt was done by Bernard Joard in 1957 to 1973 and Paulus 2005 to study the combination of pile and raft. In the conventional approach, we are usually designed in group to take a major load and some allowance for the raft to compute the ultimate capacity. There is also another version in which the load is fully utilized, in which piles operate 12% of the load capacity. This means piles are used primarily as piles reducer and ultimate load capacity of entire foundation is also increased. Research camp, I would like Mr. Rahim to come here and explain it.
Assalamualaikum. My name is Muhammad Zahid, and I will talk about the research here. So the topic of our presentation. So on this topic, there is very rare research available on the effect of contact pressure on the capacity of pile. The research is being carried out to find the effect of contact pressure on lateral capacity of pile in a pile raft system. Problem statement: in convenient pile raft and pile group design, mostly the capacity is assumed to be less than the summation of single pile capacity to pile interaction with the raft, and also the effect of the contact pressure is not considered. Now I would like to talk about the objective of our FIT presentation. So in the diagram you can see our pile and raft foundation. So this is the raft and this is the pile. So when we apply a vertical load on our raft, so due to this the contact pressure get increased, and our objective is to find the effect of this contact pressure on our pile. So methodology: to find the contact pressure on the lateral capacity of pile in a pile raft system, we use a small scale pile raft models and implemented with shear load cell on the pile ground. So we performed some tests like sieve and emission analysis. Sieve analysis is performed on sand, and from the graph we found the time is poorly graded. It's also shown here in the graph. So the model which we use in the FIT project is this one. Length of the box is 1.5 meter, its height is 1.5 meter, length of the box is 1.2 meter, and its width is 0.9 meter. The cell box was large enough in relation to the coil raft model developed to prevent the side effects of the boundary conditions. The piles, we use two things in our design. One is the pile and one is the raft. So the pile we use is of galvanized circular iron pipes having modulus of elasticity equal to 200 gigapascal with a length of 1.5 feet. Also the raft thickness is 25 millimeter having the modulus of elasticity equal to 69 gigapascal, and the dimension of the raft is 1 into 1 feet. Now I would like to call Ram.
So we use mobile collimator to ensure the same density in a soil works. For this purpose, the mobile collimator can be moved in 3 dimensions so that we can transfer the soil to every part of this soil works. So that's why we use mobile collimator. Next, installation of load cells on piles. So we installed load cell on piles to know the displacement of piles when the load is applied. So two strain gauges were mounted on a dummy pile for the temperature adjustment, and the two tension strain gauges were put on one side and two compression strain gauges put on the other for later load cells. Data logger, we use data logger so that we can collect data from the displacement of piles with the help of MATLAB. Data logger transfer the data from the soil works to the MATLAB, and we collect the data that how much when load is applied, so how much displacements are produced. So there are total 30 channels. Among 30 channels, there are 12 transducers, 1 load cell, and 17 pile load cells. And we record this data in MATLAB as a text file, and the transfer data makes a file for included graphic and analysis. This is next. So this is schematic view and this is experimental view. We collect this data logger to these files, and then data logger is also connected with the tag, and with the help of the tab circle we use this data. Next. So this is our results. When lateral load is applied on a single file, when the load initially when there was no vertical load. So when the lateral load is applied, so 11 millimeter displacement is covered. When the vertical load, the presence of vertical load, when lateral load is applied, so the displacement reduces. So we come to this point that when in the presence of vertical load, when lateral load is applied, so the contact pressure is increasing. When the contact pressure is increasing, the strength of the pile is increasing. When the strength of the pile is increasing, then the displacement is reduces. Initially, when there was no vertical load on the pile, so it covered 11 millimeter distance. In the presence of vertical load, when the lateral load is applied, so it reduces the displacement. And when the load was 5745, the displacement reduces to almost 5 millimeter. So we come to this point there. In the presence of vertical load, when lateral load is applied, so the contact pressure between the piles and soil is increases. When the contact pressure is increasing, the strength of the pile is increasing. The strength of the pile is very increasing, so the displacement reduces. And this is our experimental results we can see. So we take about 2 millimeter to measure all the data and check how much displacement is covered. So 2 millimeter lateral displacement, lateral capacity of pile is increases from 175 to 400 Newton. From 175 to 400 Newton. And the vertical load is increasing from when the vertical load is increasing from 0 to 5745 Pascal. Next please. So we come to this point that when the surface load is applied in the presence of surface load, the contact pressure is increases. When the contact pressure is increasing, the strength of the pile is increasing. When the strength of the pile is increasing, the displacement is increasing. So this is what we find in our experimental data, that if we consider this contact pressure in designing, so it will be more economical. This next. This is our conclusion. The axial capacity of single pile increases from 19 to 325 Newton at a displacement of 1.5 millimeter displacement. And the lateral capacity also increases from 175 to 400 Newton at 2 millimeter displacement. When the vertical load is increases from 0 Pascal to 5745 Newton. And the contact pressure between the soil and the rock also increases the lateral and axial capacity of pile. This was our experimental. This is what our aim was, to find that what's the effect of contact pressure on the pile. So we come to this point that in the presence of contact pressure, the strength of the pile is increases. When the strength of the pile is increases, the displacement is reduces. This is what we find, and this is what the experimental results show to us. Thank you. This was all about our presentation.
Yeah, thank you very much.
Thank you.